Assalamu alaikum, dear guys. I am Sheikh Ali and I welcome you all in today's mathematics class. And we all know that the world is seeing the very dangerous what is going on, the dangerous situation of the 21st century or maybe some centuries. And because of coronavirus, you could not come to your college and you could not attend your regular classes. So that's why I'm here to take your online class on mathematics. And you must be attentive in order to use the advantage of it. So boys, here is some steps to prevent COVID-19. You should maintain this. Wash your hands frequently with hand sanitizer or soap. Avoid touching your eyes, nose, and mouth. Cover your tissue. Cover your cup using band, your elbow or a tissue, and must be aware of this. Avoid crowded places and close contact with anyone. Okay, so let's start our today's class. Boys, can you guess from this picture what we are going to learn today? Yes. Our today's topic is statics chapter B, learning outcome. After the lesson, you will be able to apply Lam's theorem and solve problems of equilibrium force. In previous class, we solved some problems of this section, equilibrium forces, and we learned some states of equilibrium state and some formulas. And in this today's class, we learn again reviewing these formulas and solve some problems. Okay, so let's start our class. Boys, listen carefully. Okay, problem formula. Lam's theorem. If three coplanar forces acting at a point along different lines be in equilibrium, then the magnitude of each is proportional to the sine of the angle between the other two forces. Let three coplanar forces P, Q, and R acting at a point O along OX, OY, and OZ be in equilibrium, then you can say that P divided by sine angle between R and Q is Y or Z, and Q divided by sine angle between R and P, that is Z or X, equal to R divided by sine angle between X or Y. So, the formula 2, condition of a system of coplanar forces are in equilibrium. Let a system of coplanar forces P1, P2, P3, Pn and their resultant R acting at O and makes angle alpha 1, alpha 2, alpha 3 and alpha n and theta. The resultant makes angle with OX line. And taking the resolved parts of the forces and their resultant along and perpendicular to x. We know that the result part of resultant and the result part of other forces, summation of other forces are equal to 0, are equal to same. So if that, then R cos theta is the result part along the resultant of result part OX along OX, and P1 cos alpha 1, P2 cos alpha 2, P3 cos alpha 3, and Pn cos alpha n is the result part of P1, P2, P3, Pn forces along OX. And sum of these result parts equal to the resultant result part, and that's equal to 0, because we know that here the forces are in equilibrium, that's why the resultant is 0. So that's equal to 0. And also perpendicular to OX, we get R sine theta equal to P1 sine alpha 1 plus P2 sine alpha 2 plus P3 sine alpha 3 plus dot 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 plus p n sine alpha n equal to r2 equal to 0 similarly. Okay, now here is some problem we solved. Previous class we solved 3 problems and today we solve 5 problems. Boys, if you solve these 8 problems and what I should give in previous class was 3 or maybe 4 homework, and today's I give you some homeworks. That's I think is that's for all of this section. Okay, if two equal forces of magnitude P acting at a point at an angle of 60 degrees is held in equilibrium by a force of magnitude 15 Newton, find the forces. So the system is in equilibrium. Solution: let two forces P and P, two equal forces, let the forces P, and acting an angle 60 degree on, now we apply the parallelogram law. According to the condition, magnitude of the resultant R equal to 15, that is 15 squared. So here is the third force, not using resultant. We just call this resultant because if three forces are in equilibrium, then the two forces, then then the third force we should call it resultant. Okay. So here R equal to 15 and 15 square, that is R square equal to P square plus P square plus 2P into P cos alpha, alpha equal to 60 degree. So here R equal to 15, that is 15 square equal to 3P square, since cos 60 degree equal to half and 2 cancel. So here P square and here 2P square, we get 3P square. So here P square equal to 15 into 5. So that's why P equal to 5 root 3 Newton. Okay. So boys, in previous class we said that if three forces acting at a point and they are in equilibrium, then the third force, any the resultant of two forces will be third force. Then the three forces are in equilibrium. Okay, now problem 2. If two forces P and Q acting parallel to the base and length of an inclined plane respectively, would each of them singly support a weight W on the plane? Prove that W equal to PQ by square root of P square minus Q square, where P greater than Q. So there are two forces P and Q, and singly P force makes an equilibrium with the weight W on an inclined plane, and Q acting along length of the inclined plane, and it also makes equilibrium with the weight W on inclined plane. So there is a figure for first. First we say that Q is acting along the inclined plane, and alpha makes angle alpha with OX line, and W is the weight is perpendicular to OX, and here is alpha and it should be alpha. So there is a reaction force, that is R, that is R reaction force. So, and there are three forces R, Q, and W. The three forces Q or W are in equilibrium at point B. So now we can use the Lami's theorem. By the Lami's theorem, we get Q divided by sine. We know that the sine angle between R and W. R and W is it is total 180 degree, and there it is alpha, so 180 degree minus alpha equal to Q, W. W divided by the sine angle between R and Q, that is 90 degrees. So W divided by sine 90 degree equal to R divided by sine angle between Q and W, that is 90 degree, and here it is alpha, that is 90 plus alpha. So from first and second condition, we can say that W by sine alpha, we know that sine 180 minus alpha equal to sine alpha equal to W by sine 90 equal to 1, so that's 1. So Q equal to W sine alpha, so W square by Q square equal to cosine square alpha, that's 1. And now the second. Here we place the P force along the base or horizontal. Okay. So here it is also an inclined plane. Here is W and there the normal reaction R. So first, then at point B, there are three forces W, P, and R prime. These three forces also makes an equilibrium. Okay. So by the Lam's theorem, we can get P divided by sine 180 degree minus alpha as usual. W divided by sine 90 plus alpha. W, that means here is 90 and it is alpha, that is 90 plus alpha. And R prime divided by sine 90, this is 90. So P divided by sine alpha plus Q divided by sine alpha from first and second the ratio we can get. Now we can write P equal to W sine alpha by cos alpha, that is tan alpha. And now we can write W by P to the cot alpha, W square by P square equal to cot square alpha. From now 1 minus 2, we write the W square by Q square minus W square by P square equal to cosine square alpha minus cot square alpha equal to 1. We know the trigonometric formula, that is 1. So now take common W square and taking LCM, that is W square minus Q square by P square Q square equal to 1. So W equal to PQ by square root of P square minus Q square, high P greater than Q. That's the problem 2 is really important. And now problem 3. Two ends of a string is attached to points on the same horizontal line. A smooth ring with W slides over the string. A horizontal forces P and is acted upon it in equilibrium position. The string makes angle 30 degree and 60 degree with vertical. Show that P equal to the force P equal to W into 2 minus root 3 and tension of the string T equal to W into square root of 3 minus 1. So that's the really tough question, and you listen carefully, boys. So first, let the ends of the rope are tied A and B due to horizontal forces P. The strain is stable at point C and Wx along C. Wx along C. Wait. The ring can move very easily, thus the tension of the ropes is equal everywhere. Let the tension of the rope T, okay, because the ropes is equal everywhere, okay, and move very easily. That's why the tension is same. So here angle ACD, because the force is this portion, so that's here is the weight is ring is along this side. Okay, if the force is along this side, so the rope is this side. So angle ACD equal to 60 degree and angle BCD equal to BCD equal to 30 degree. CD is perpendicular to AB. According to the condition, the resultant of the forces is 0 because this is in equilibrium. Thus, taking resolved parts of the forces along P, because here is 4 forces W, P, T, and T. So we cannot use the Lam's theorem. Here we have to use the resolved part formula. So here along the P forces, we take along P forces. So P resultant equal to 0, that is summation equal to 0. So that is P cos 0. The angle between P and P is 0 degrees. So P cos 0, T cos, here it is 60, 30. So it is 90 minus 30, and here it is 90 plus 60, T cos 90 plus 60, and W it is 270 degree. So now here P cos 0 equal to 1, that is P cos 90 minus 60, it is cos 60. Okay, cos 60 we can write that is sine 30. Okay, and here t cos, and we can write here it is t sine 60, and w 2 cos 270 degree equal to 0, that is w equal to 0. So now here we write the p into sine 30 equal to half, that is t by 2, and sine 60 equal to square root of 3 divided by 2t. So here p equal to 1 by 2t is equal to 3 minus 1. So again, taking result part of the forces along CD. So that's P sine 0 degree plus T sine 90 minus 30 degree plus T sine 90 degree plus 60 degree plus W sine 270 degree. So now that sine 0 degree equal to 0, so that's why P vanish. So here T, that is cos 30, and that is cos 60 minus W sine 270 is equal to minus 1, that's why it is minus W equal to 0, and cos 30 degree equal to square root of 3 divided by 2 t plus, that is half, so half t, and equal to W. Okay, so now t equal to 2W by root 3 plus 1. And now we again putting the value, and we know that we cannot we cannot give any answer in while the denominator is in irrational number. So we have to multiply the conjugate of this irrational number, that is root 3 minus 1, and multiplying this we get 3 minus 1 and root 3 minus 1 in, and w equals w into root 3 minus 1. So from again equation 1, putting the value of t, we can get the value of p, that is p equal to 1 by 2 w root 3 minus 1 whole square, that is 1 by 2 w 3 plus 1 minus 2 root 3, that is w into 2 minus root 3. That's the important, that's the result. So boys, this is the one problem for putting the result into parts formula. Okay, now problem 4. The rope of length A is attached to a vertical wall and a point on the surface of uniform sphere of radius A. If the weight of the sphere is W, then show that the tension of the rope is T equal to 2 by root 3 W. Okay, so here it is. Let the sphere has center C at the point at B the wall AB and touches the sphere. So here is a reaction force of the wall along the BC, that is R, and the weight of the sphere is down the C, and the tension of the rope along CDA is T. That's three forces are in equilibrium at T, at C. So according to the Lam's theorem, we can write T divided by sine 90. The angle between R and W is 90 degrees, so sine 90. W divided by sine 180 degree, that is 180 minus ACB. W divided by the angle between R and T, that is whole is 180 degree, and W, that is 180 degree minus this angle is angle ACB, and R divided by sine angle between T and W, that is angle ACE. Okay, so now we can write T divided by, from first and second, T divided by T equal to, that is sine 90 equal to 1, that is T equal to W by sine ACB. We know that that is an right angle triangle, so sine angle ACB is AB by AC. So W by AB by AC equal to W by CA by AC by AB. So W into AC by AB equal to W into AD plus CD. AC means AD plus CD. So here AD equal to and we can write AB as square root of AC square minus BC square. So now it is W equal to W into A plus A, AD equal to A, and CD equal to the radius also A. And AC square AC is A plus A, so A square minus A square. So when AD equal to A, BC equal to CD equal to A radius. So here 2A by root 3A square equal to 2 by root 3W. Okay. Now problem 5. Two forces P and Q acting along horizon and at an angle 30 degrees with the horizon respectively together can support a particle of width W. Find the value of P and Q. I can repeat the question. Two forces P and Q acting along horizon at an angle 30 degrees. This is horizon and it is 30 degrees. So with we can support of the particle weight is 6 kg. Find the value of P and Q. So let at point O the forces act along sides OA and OB are of magnitude P and Q, which can keep a weight of 6 kg in rest, that's downward along OC. So from Lami's theorem, because here at O point three forces are in equilibrium, a P force, Q force, and W force, that is 6 kg weight, are in equilibrium. So P divided by the angle between Q and C, that is 90 degree plus 30, 90 plus 30, and Q divided by the angle between sine angle between P and C, that is 90 degree, that is Q by sine 90 equal to 6 divided by sine 180 minus 30, that is total 180, 180 minus 30. So now we can write P divided by cos 30 degree equal to Q by 1 equal to 6 by sine 30. And now we can write from first and third equal to 6 cos 30 by sine 30, that is 6 cos 30 equal to 6 root 3, and also Q equal to 6 by sine 30 equal to 12. So boys, that's the 5 problem I solved here. And if you have any query, please write down, ask your question in chat box. Okay. I hope if you all are understood my class, and if you do this maths, this I solve and I bring you in your homework, and then you have no problem, I think. Okay, now homework part. A row of length L is attached to vertical wall and a point on the surface of a uniform sphere of radius A. If the weight of the sphere is W, then show that the tension of the rope is T equal to WL plus A divided by square root of 2AL plus L square. Which problem I solve? That's the similar problem is here. Okay. Now number 2, two extremities of the rope ACD are attached to two fixed points A and B in the same horizontal line. A given weight W is knotted to a point C in the rope. Prove that the tension in the portion CA is WB by 4C del C square plus A square minus B square, where A, B, C are the sides and del are the area of the triangle. So I solve 8 problems and I will give you 5 problems. So that's 13 problems are important. Okay. So before ending my class, I again reminding you that the world is going through a pandemic situation, so you have to maintain the steps of prevention of COVID-19. So first, avoid contact with others, maintain 3 feet distance, and You should avoid going out unless it is bad necessary. Okay, so stay cautious. Cautious is really important because our country, everybody is not cautious about COVID-19. So you remain cautious and stay home, stay safe, stay fine. Allah Hafiz.